So we're going to look at number 2 for the 2018 AP Chemistry free response. If you have not worked this yet, pause the video. You can work this problem and then return to the video when you're ready to go over the explanations and look at the point distribution. So we're going to first in this video look at the first half of this problem, A, B, and C. The rest will be in a separate video. Jumping right into it, we are given just an empty circle for oxygen, darkened circle for nitrogen, and we are told that in the box below, down here on the left, we are to draw a particle level representation of the reactant mixture of NO and O2 that would yield the product mixture shown on the right. And in our drawing, we are supposed to represent oxygen and nitrogen atoms as indicated below. So this is kind of a reverse limiting reactant problem where we are given a balanced chemical equation and we are shown what is left when the reaction is complete. We need to backtrack and find what is in the beginning. So we have to start over here, and we notice that we have 1, 2, 3, 4 NO2 molecules, and we have 1, 2, 3, 4 NOs that are left over. So when we look at this to try to figure out our answer, we do have the balanced equation to go off of here, and this is our count. So the fact that NO remains, that's our excess reactant. Therefore, oxygen is our limiting reactant. So oxygen has a 1:2 ratio with nitrogen dioxide. If 4 of these are made, we need to figure out how many oxygens reacted for that to happen. So 1 oxygen would make 2. Another oxygen would make 2 more. Due to the ratio and the fact that 4 NO2s are made, that means we would just have 2 oxygens on our reactant side. And now for NO, well, we know we have 4 left over. Well, if it's 2 oxygens, well, every 1 oxygen reacts with 2 NOs. So this one's going to react with 2. And this one's going to react with 2. And here's where it's really easy to make a mistake. You also have to draw the ones that are left over because they were present there in the beginning as well. So the answer for part A, we needed to see how many NOs and O2s there are. There are 2 oxygens, and we have here 8 NOs. Part B gives us a new reaction right here, and we're giving the enthalpy, the entropy, and Gibbs free energy overall changes of the delta for this equation. The student begins with an equal molar mixture of our 2 reactants in a rigid vessel, and we reach equilibrium at 298 Kelvin, and we're asked to solve for K. So this is where the equation sheet comes in handy. If we refer to our equation sheet, then we see a few different ways that K pops up. One of them involves the Gibbs free energy, or the change in Gibbs free energy. So the change in the Gibbs free energy equals negative RT ln of K, or minus rat link is how some students remember this. And remember to be careful. There's a couple different R's in AP Chemistry. Our ideal gas law, or gas version of R, 0.0821 liter atmosphere over mole Kelvin. Or we have our value of 8.314 joule per mole Kelvin. This involves energy, this involves joules, so that is the one that we will use. So we divide by negative RT, and to get rid of our natural log here, we'll do erase to both sides of our equation. So K is going to equal erase to the negative 870 joules per mole, which was the value we were given for delta G, divided by 8.314 joule per mole Kelvin, times 298 Kelvin. Notice I've already made a unit change here. We can't put the kilojoule per mole version in because of R. You either have to both be kilojoules or both be joules. I just made them both joules, and so the joule in our R would cancel out that joule. So when we plug this in a calculator, we get a K value of 0.70, and that is how we would write it, because when we go back to look, 0.87, 298 Kelvin, these two values we were given, 3 sig figs and 2 sig figs. 2 sig figs is the smallest number of sig figs, so that is going to be what we use for our answer. Part 2 says, what if the pressure of the two reactants are both 1 atmosphere? Will the pressure of N2O3 at equilibrium be equal to 1 atmosphere? And it wants us to justify our answer. And this is a tricky little question, but we could just go back and refer to the fact that we just got a K of 0.70. And we know that our equilibrium constant is product over reactant. And since it is equal to a value less than 1, we know we're going to have a lot of our reactants left and not as much of our products made, which is why we would give for an answer for part 2 that we would not have 1 atmosphere of PN2O3 because our K value indicates that we're not going to make a lot of product. And then finally in C, the student hypothesizes that increasing the temperature will increase the amount of product in the equilibrium mixture. Indicate whether you agree or disagree with the hypothesis and justify our answer. So looking at the balanced equation right here, this is an exothermic reaction. The delta H is negative, and I always tell my students, if you're exothermic, add heat on the product side. If you're endothermic, write heat on the reactant side. So if I increase the temperature right here, we're at equilibrium, and increase in the temperature, we're going to be adding heat. That is going to cause a shift to the left, away from N2O3. So our answer for C would be that the amount of N2O3 will not increase. So we disagree with the hypothesis due to the shift that occurs when heat is added to our mixture. So the points for these problems, there was 1 point in A for correctly representing NO and O2, and it was 1 point for correctly representing the conservation of atoms. In B, it was 1 point just for getting the correct value of K, 0.7, and in B part 2, it was 1 point for correctly saying that N2O3 would not be 1 atmosphere, and you needed to relate your answer to the K value. And then finally, at the end, part C, it is 1 point is earned for the correct choice that the value of N2O3 will not increase, that we disagree with the hypothesis, and you had to relate it to the shift that would occur due to Le Chatelier's principle because of the increase in temperature and this being an exothermic reaction. So there were 5 points for the first half of this problem in A, B, and C.